Hey everyone, my name is Liran and I'm a product architect at Dynatrace. It's great being here for an Ask Me Anything. It's been a while since my last one, but it's really great being back here. Today we're going to be discussing our new generative AI at Dynatrace and conversational AI and how we've built some cool stuff around DQL so that AI can run DQL queries for you. DQL is essentially the Dynatrace query language, but let's kind of roll in some of our panelists who are experts on the topic so we can get this started. So with us today, we have Martin, who is the lead researcher on Gen AI in Dynatrace, and we have Thomas, who is the lead scientist for Gen AI as well. So let's kind of welcome them and get started. Hey, Thomas. Hey, Martin.
Hi, Liran. Hi,
Hello, hi everyone.
everybody.
So let's kind of start with an easy question. Where is AI even exist? Where does AI even exist in the Dynatrace platform?
Well, I mean, AI has really been around for a long time already in Dynatrace. Of course, the generative AI additions, what we will mostly focus on here, that's fairly recent. But it's been all over the product for a long while. We've kind of categorized that in different applications. Thomas knows this a lot better than I do. So we have this kind of pyramid with the three different aspects. The predictive AI part, which is more the traditional machine learning, right, with forecasting, anomaly detection, and these kind of things. Then the causal AI, some core competency really of our product. That's the main purpose here is a root cause analysis. So if something goes wrong, what did actually cause it? That's a very different kind of AI than what we are typically talking about these days. And then we have this generative AI part with this newest addition with Davis Copilot, which we will talk about a lot more today, which at the moment serves mainly two purposes. One, you already mentioned, is query generation in our Dynatrace query language, but then also like a more chatbot-like service where you can have answers question for the product. And in the future, we'll be adding a lot of other features to that. That's definitely the plan and on the roadmap.
But I have so many questions about what you've just said. Also, the audience might have, so it's worth noting this isn't Ask Me Anything. If you have any questions, please write them, share it with them, and we'll do our best to answer them. So let's get started with kind of when did we start integrating conversational AI into Dynatrace and what were we setting out to achieve and how close it is to what we ended up with?
Yeah, so maybe let's say, when we started our endeavor was, as for many companies, some little time ago, some little time after ChatGPT has been published by OpenAI. So our journey began roughly in 1.5 years ago, mid of 2023, where the leadership team set out our vision, what we finally want to achieve when leveraging generative AI in the software intelligence space. And it became obvious that we could also leverage this for our new Dynatrace platform with DQL and all the cool stuff which is available there, and helping our customers onboard it. So the idea was early on born to do something which other companies do when they generate SQL. We wanted to generate DQL and have a nice natural language user interface for that.
So if people aren't familiar, in Dynatrace, we take all of the data we're collecting, especially the signals data, and we're putting it into one big database we call Grail. And then we have this DQL language, which is a mass data processing tool that allows us to process all of this data at scale. And it's a very tailored language for observability and what we're trying to achieve. And you can do amazing things with it. But personally, I'm still learning the ropes. And I know many of our users aren't such experts in it. So it's amazing to provide them with a natural language interface. But how do you actually go about that? How do you, as you mentioned, you have ChatGPT, but how do you go about teaching AI and building this new skill for running DQL queries or building DQL queries?
Yeah. So, if you want, Thomas.
So back then, when we started, maybe I just talk about 2 or 3 challenges which are there, which are maybe different when someone talks about code generation with generative AI, which back then when we started our endeavor have already has already been there. So ChatGPT can fluently talk Python. It can, to some degree, fluently generate SQL and things like that. So the question is, okay, why doesn't it fluently generate DQL? And obviously, it's the case that DQL was invented later than SQL. So when these generative AIs have been trained, right, in their data sets, they have all a cutoff date. Not that much of DQL has been already published in the internet and on GitHub. So that's the reason why we needed to do a little bit more effort there to teach it. And on the other hand, the Grail data lakehouse is also kind of a more schema-free data warehouse, and to teach a generative AI to produce a meaningful DQL statement, you also needed to teach the existing data and the existing schema. So that's kind of what the two main challenges there, which we had to solve.
Let's zoom in a second on the language stuff. You mentioned SQL. Now I'm guessing SQL, there have been dozens, if not hundreds or thousands of books written on the topic. There are so many queries out there in GitHub, and that is where
Exactly.
we keep hearing about AI being trained on petabytes of data. There is no way you can get petabytes of data for DQL queries. So kind of you would have
you
very
don't
little data
need
to
quite
work
that
here.
much. But I mean, one of the first biggest challenges we had actually was to make sure that our tool does not give back SQL queries to the user.
Exactly.
Right?
Yeah.
That was really the first challenge, because it just very naturally did that. There's so much on the internet. Even now with the newer models, they have, I mean, our DQL documentation is of course public on our web pages, and all the big models, they have also seen this data. I mean, if you now ask ChatGPT or Anthropic models or whatever, something about DQL, and you are very specific about the question, then you have a good chance of also getting at least some simple DQL queries back, right? Okay. But of course, you really have to ask very specifically for DQL, otherwise you are much more likely to get SQL. And that's also what we saw, of course.
Just an
So how did you
anecdote. I just wanted to chime in with a little anecdote. When we internally, as our backend, right, we are using the OpenAI models. When we did an upgrade to a more later one, we saw an increased tendency to spit out SQL again instead of DQL. So they really know their stuff when it comes to SQL. Yeah.
So how do you go about compensating for such a lack of training data?
Yeah, I mean, it's a challenge, but in a way, it's of course also helpful, because the purpose what the SQL does is very similar in the end to DQL, right? So it helps if the model already understands SQL. It's actually easier to teach it DQL as long as you make sure that it does not provide actual SQL, right? It has already kind of learned some underlying structure of what queries look like and so on. So you just have to teach it the deltas and not right from scratch how to create a query. So first is just make sure it understands it should produce something different, but still it's a query, right? Query language. Yeah, and then of course you have to, in our first approach that we have taken and what is still now used in the product, with using ChatGPT, with using a GPT-4o models actually now at the moment. If you use them, we don't train them or fine-tune them in any way. That would be just way too costly and also not very useful probably. What we do is we provide all the information that it needs in the prompt. We add all kinds of information, and that's a lot of information, right? Because if you just think a human being, if they want to create a query, all the information that they need, of course, the models also need that. So that means on the one hand, information generic about the language, like what is the syntax, what are the commands, what are the functions, all that. But it also, as Thomas already mentioned, it needs to know about the data. What are field names called? What is, I mean, it's schema-less, but it's still some structure of how the data is stored, right? What are the relations? What are the semantics there? So there's a lot of information that is needed. And of course, we need to make sure to provide all that information. And and also not too much information, and it gets confusing, but really tailored to the specific question. That's probably, the main challenge that we have.
So in some ways, you're essentially reteaching the GPT DQL with every question. You're retraining it.
No,
Yeah,
not at all. That's very important distinction because ChatGPT doesn't learn anything. It starts from scratch every time we call it again, right? It doesn't remember
Yeah.
everything we had before. And
What-
that's a good thing. We don't want it to remember what our customers have asked it, right? All the customer data is fully safe. It's sent somewhere via, of course, this Azure interface, but it's guaranteed it's not stored or used for training or anything like that. It's just used then in this very specific context to answer that one question. And perhaps follow-up questions, right? Not so much at the moment, but maybe in the future, but not in any then. If you start a new conversation, you again start from scratch. We are not teaching it anything, at least not anything beyond a short-term memory, if you want the human analogy.
Yeah. So this sounds like one of the most complicated projects of prompt engineering I've heard. How do you go about building such a big prompt to make sure it has the right data, that it doesn't confuse, that you don't run out of tokens, and so on?
Yeah, so but that's a very good question because when we first started, I mean, things have changed in the last 1.5 years. So when we started out with the first approaches there, we needed seriously to think about the context size and the prompt length which we're allowed to use. So we have a multi-step approach at the end, right? We don't compile one gigantic thing and ask the LLM to spit out the SQL, but we do it more like in a way first give it some content and say what would be the rough plan to come up with a TQL query, and then don't focus yet too much on the syntax, and in another step it should focus more on the syntax when it already knows where to look up the data. Is it either events or time series or whatsoever, whether it basically has figured out this kind of let's say more semantic related stuff in the first step, and then later on concentrate on the syntax. If it knows that's the rough plan how to build a TQL query, okay, I figured it out, and now let's use do the syntax stuff. Yeah.
So essentially, kind of you broke it down into multiple steps, and you start out by kind of a discovery, kind of tell us what you need, and then you kind of feed it further data on the specific tasks.
That's fair to say. Yeah. Exactly.
Sounds quite complicated. Would you do differently if you started today?
Yeah, maybe Martin has to say more because we have, from my end, we developed this approach and which is in production now, but Martin's team is evaluating other possibilities too. So maybe Martin, you can elaborate on that one.
Yeah, and first of all, let's just say, I mean, it's of course very complex, but it's not like, we went from zero to what we have now, but it was always baby steps. You add one thing at a time, and at some point it gets more complex, and then you maybe reorganize things. And yeah, if you know already what we know now, maybe you would find a more direct way to where we are now, but more or less, I think you would arrive in a similar place. Yeah. The alternative, of course, to do this very heavy prompt engineering is to train your own model, or at least to fine-tune an existing model. And that's something that we are also investigating and evaluating at the moment. In this case, ChatGPT, GPT-4 is a huge model. It's not publicly known how large it really is, but at least the initial GPT-4, there are quite reliable sources that it was more than 1 trillion parameters, right? Newer models are slightly smaller. Now, if you train, and that's because GPT-4 can do, almost anything that you can do with language, right? If we, as in our case, we have a very specific purpose, just creating one specific thing, a TQL query, then you should be able to get away with a lot fewer degrees of freedom, with a lot fewer parameters. So the idea behind that is then to start with a smaller model that is 2 to 3 orders of magnitude smaller, typically some public model, the usual suspects like Llama, Mistral, and so on, and then to actually continue training this model, so that's called fine-tuning, specifically on creating TQL, and see where you can get with that. That way you can already teach the model all the generic stuff like syntax, command names, what they do and how to use them and so on, then you don't need to add that to the prompt anymore. Of course, what you cannot do is you cannot teach the model in what specific way a specific customer is storing their very specific data. So you still have to add some information to the prompt, at least potentially, to answer some of the questions. But yeah, it gets a lot less heavy on the prompt engineering side.
So this sounds all incredibly complex and in a very evolving environment where advances on the outside keeps changing, technology keeps changing, breakthroughs are made, and I'm wondering were there ever any moments of despair when you thought this is gonna work?
Yeah, so as you mentioned, at some point in time, you need to make a decision to nail something down to get into production, right? If you always try to catch up with the latest, greatest achievements whatsoever, you do nothing, then changes, right? That's also not something we can do. So at some point in time, we needed to fix the model version, which was to some degree one problematic point because all the timelines were really short to get transition from one model from the supplier to the other, having all the testing in place, make sure that everything works again, does not break, and things like that. On the personal level, I have to say, it's very nice to work with this kind of generative AIs, but at the end, it's more like you're talking to I don't know, somebody who is learning to do something. And as a developer, you often are used to when I code it in that way, it works in that way, right? And with generative AI, it's more like, as a friend of mine used to say, he's not the prompt engineer, he's a prompt poet. Because whatever you write there, right, it may get accepted or may not get accepted. And once we had a discussion with some experts from Google back then, he also said he thinks of prompts like jokes. Not every LLM laughs at them. So that was also a nice metaphor how he put that. And this can at some point in time make you cry. That it's not when you do all the CI/CD stuff with proper testing and regression testing, that due to the, let's say, creativeness of LLMs, even if you try to set all parameters that they are not, they still are, makes you a little bit cry of flake tests and stuff like that. So that was something to learn, right? To deal with this kind of uncertainty there.
Yeah, I've been at a conference. There was a guy who had a whole talk just about how if usual programming is more like, what did he compare to, machines or something like that, then LLMs we should view as pets essentially. So like a cat. You can teach a cat a lot of things, but then if you ask it to do something specific, you can never be sure it actually do it, right? It may do it or it may not do it. He really had a whole talk
that's
this analogy.
that's also a nice comparison. Yes, exactly. Yeah.
If I were to develop something similar, trying to teach AI something, build it into an app of some sort, what would be your tips on how should I get started and what should I watch out for?
It depends on how fast you really want to get into production with it, right? So, there's tons of libraries out there, especially in the Python world, which give you a good starting point, and for developing all this kind of retrieval augmented generation approaches where you pull stuff together and give it to the LLM to read to make sense out of it and then get your question done. But what I could say from our journey is that take your time to properly test stuff, right? And take your time to set the scope of expectations, what it should be able to do and what it should not be able to do when it comes to this kind of, because what we had at hand, what we wanted as an output is not the poem, not the text, not the speech or something like that, where at some point it doesn't exactly matter so to say, how the sentences are formulated, as long as the tone and the ground, let's say, thing is okay. But if you want to use it in this technical space where we are, the groundedness, faithfulness, correctness of the outputs are things to look at thoroughly from the beginning.
Mhm.
Yeah, and I think one important aspect is, I mean, when you are building something like that, it's always a whole system, right? It's not just a model, but it's a whole system around it. And you should always think careful what parts of this system you really want to develop yourself and which you can take more or less off the shelf, right? I mean, it's already with the models, right? You can just make API calls to a model, or you can host your own models, you can fine tune, you can even train from scratch maybe on models, even that's maybe quite prohibitive. But also if you use any databases, if you use like this retrieval augmented generation approaches, they're more or less managed approaches for all of that, which I mean save a lot of effort, and in particular then also on the maintenance side. So if you want to do something quite generic, then very often you will find solutions, at least for parts of your system, that already exist. And in the end, it will be a lot cheaper and easier and faster and so on, and to use them. If you want to do something very specific, like in our case with DQL, that's of course not a typical use case, right? And not something that you can expect a system or model already to excel at. Then it's worth thinking about whether you want to build something yourself. If it's just, typical, I don't know, answering something from your documentation, that's typically finding the right document, serving it to the LLM, and the LLM summarizes it. And the models are great at summarizing. You don't need to come up with your own model for summarization. That just doesn't make sense. So always think about what you want to build yourself and what is already there, what can you use easily and integrate. Of course, it may cost a little, but always less than hiring people to develop it and maintain it and so on, right?
Yeah. And there was a lot of, as Martin mentioned, a lot of stuff was built during the time when we started our project, right? Which we, to some extent, had to develop on our own because it was not available as a third-party service. For example, the whole AI offering of our main cloud provider has not been available back then. Now it is, all right, and so this would probably be things we would do differently now.
Mhm. So follow up. So first, I just want to follow up to some of our audience. So Jakub, great to meet you. We have a pretty big office in Gdansk. And for Yannick, I don't think we have the right experts here on the call. I would recommend you post it in the Dynatrace community. There are better suited experts there to help you with our extensions platform. You guys mentioned a lot about the system here. So I'm wondering, we've built a whole system on top of this. So where can I see it in action?
Yeah, so obviously the natural language to DQL part is integrated in our famous notebooks application, where instead of a DQL cell, you open a Copilot cell, and there you go. There you can enter the natural language, and then it will be generated and executed for you. And the same is also available in dashboards, right? Where you also typically enter your DQL query to be visualized. There you can also ask it in a natural language to do the DQL generation for you. That's the NL to DQL part, natural language to DQL part, which is officially called, I think, AI assisted notebooks. And the other one is the conversational interface, which you can basically just start. I think it's Control I in the Dynatrace platform, which opens up the dialogue, and you see a classical ChatGPT-like interface where you can do your conversation.
At Dynatrace, we keep talking about the fact that we allow developers to develop on our platform, build custom extensions, doing tons of stuff that we haven't thought of originally. And I'm wondering, are any of those Gen AI capabilities available to developers building stuff on the Dynatrace platform?
Yes, there are. So the Dynatrace Copilot is built as a platform service, like many other platform services, like our Grail service, document storage, and things like that. And they are currently as experimental APIs available. So if you are in an app developer, if you are in a workflow and use a TypeScript node, or if you're in a notebook and use a TypeScript cell, you can go and access our APIs there. And going forward, obviously, it's planned to make those integrations for others easier. So, for example, there is thoughts about for the workflow having a direct Copilot workflow action so that you can directly use it in your workflow with proper input and output stuff. There is for the developers handing over context from one application to get the conversation started, right? So that you in the future maybe that the conversational interface can in natural language explain your, let's say, Davis problem, which the causal AI found, is handed over to generative AI to let it explain, right? Or yeah, exactly. So there will be possibilities that this generative AI can be integrated in apps, in workflows. Content can be handed over from one location in the Dynatrace platform to Copilot.
Sounds good. We just got our first question. I think the first question you can answer, Thomas, about how did we test AI. I think you touched briefly upon it around, you mentioned CI, but we'd love to hear more about how did we test it both in manual testing, but also in the automation.
Mm-hmm. Yeah, as I said, there were several angles to it, and also Martin can then elaborate on it. They're also heavily involved in coming up with proper test procedures there. So, I mean, first of all, in order to test something, as always in machine learning or AI, you need some data, which gives you the ground truth. What's the input? What's the output? Right? What's the desired output? And for that, we have various scenarios how to get to these data pairs, especially when it comes to natural language to DQL. When you go into the notebook, you actually have the possibility for feedback, right? You can say, okay, this generated DQL was what I was expecting, or it was crap, and then you can give thumbs up, thumbs down, and this feedback then helps us to collect pairs of natural language to DQL pairs, and which we will integrate then into our testing framework. What we also do on the, let's say, on each deployment, we have such a test set, and with each change to the whole system, what Martin mentioned, it's not just the language model, but the whole prompt engineering and generation approach. We have that. We run all these tests during each build, and when we deploy, we also monitor that one back ingesting, so to say, the results of this regression test into Dynatrace itself. So basically, we are using Dynatrace to monitor Copilot. So here we touch the whole topic of AI observability, and have the whole have all the metrics which generate during testing available in dashboards and notebooks to see whether we improve or degrade over time.
Yeah.
Martin, anything to add?
Yeah, sure. I mean, yeah, so in general, I mean, we have these two kinds of tests, if you want. They are, of course, related. The regression testing, what Thomas was mostly describing here now, where we just make sure that, you know, if we introduce some changes that should not really change the output, at least not significantly, that it actually doesn't happen. Then we have other kinds of testing where we actually want to see differences. Right? For example, now if we test our own models versus GPT-4o, we want to be able to compare them and see at what point we get better than the model. So that for that we need more elaborate tests and tests where we can actually see differences. And this is, yeah, it's actually quite involved. We do also some kind of bootstrapping and semi-automated generation of data. So starting from smaller amount of manually annotated data to then actually use also for large language models and other possibilities to generate test data based on actual user questions that we had. So it's quite a tricky business. We invest quite a lot of time into that. But of course, it's also very, very relevant, because if you're not even able to tell if you are getting better or not, then you're just flying blindly. So we take that very seriously. And then for the conversational, for the query generation, in some ways it's quite easy, because we have at least one metric that is very simple and objective, and that is whether the generated query can be executed or not, whether it's a valid query or not. So that's not yet sufficient, of course, because we also want the query to relate to the question. So it's not sufficient to be a great answer, but it's at least a necessary condition already, something that we can and something that can be quite easily tested. Then to go beyond that is actually a lot more complex, and we have quite an involved framework to do that. Where essentially we test the ground truth and the generated query, whether the records that they return, whether they are similar or even identical, which again has lots of complications. One of them being that time changes data, right? We keep ingesting data, throwing out data. So if you test the very same query, a few seconds apart, you might actually get different answers. So there's lots of problems, but overall, it's working. It gives some additional handle. And then a totally different thing is if you go away from queries to actual conversations, it gets even trickier, because then it's not so clear, not so easy anymore what to test, because you cannot expect literally the same answer as you have in the ground truth, right? So you need to do some kind of semantic comparison. That's also what we do, some semantic similarity. And then there are these methods, this so-called LLM-assisted evaluation, where you essentially give your ground truth and the generated answer to an LLM and ask it, are those similar enough for you? Do you think it's correct? And some more involved things, like when we have this retrieval augmented approach, we serve documents to the LLM to answer the question. And then when we get back the question, we can again throw it at it and ask it, so this answer, is it actually grounded in the document that were provided? Because if not, there's a high possibility it was made up, it was hallucinated, as it's called, right? But there's lots of different angles, and it's a lot harder, the whole evaluation, than in classic machine learning applications, where one specific question typically deterministically has exactly one correct answer, right? Language is not like that, at least natural language, human language. But after putting a lot of effort into it, I think we've made very good progress there as well.
Awesome. I see the audience is happy with the results. Jakub mentioned it earlier. And good morning to you too, Deepak. Now, while we're waiting for more questions from the audience, I'm wondering, kind of from your perspective, what's the future of generative AI, Dynatrace? What new features you see upcoming in this area? Obviously, what you can share here.
I mean, I would like to start with something that we observed very early on when we started to develop this natural language DQL feature. Because the first thing we actually built was something generic, as Martin mentioned. We were concerned about teaching the ChatGPT models that the DQL can be generated out of, let's say, static information, like if you go to docs.dynatrace.com, you can read about the structure, how Dynatrace ingests the structure. Now what is called the semantic dictionary. It explains all well-known fields and everything like that. But Dynatrace also is very open to ingest data via OpenPipeline, via different sources. And we also wanted to make Copilot to understand whatever the user is ingesting. So you can ingest your own favorite, KPI about the services you are monitoring. And we also want Copilot to understand that. So we very on realized that we also need to, let's say, at least periodically look into the Grail data and make excerpts of this data available to Copilot too, right? And that is what we internally in the codename was specific queries, right? So now I think we released it somewhere in January. no, sorry, January. That's now somewhere in October that you can ask Copilot about your own metrics, for example, or your own field names, and um, even values of fields are considered, which are interesting there. So we are going from talking with the documentation about a conversation with the data you actually with the observability data you actually ingested. And I think that's the actual path forward, that we want to invest more and more into this direction, that Copilot is really aware of the actual environment which is observed with Dynatrace. Right? That's the broad scheme of where we want to go. Yeah.
As the product architect, I'm working on application observability. I also own logs, and there are so many differences in the data we're getting. There's a huge difference between the documented stuff and what could be there, what's actually there, whether it's about volume, types, attributes, values. And there are so many interesting questions we can ask if AI will actually look at the data in practice and provide more guidance to the user about what might be of interest.
Yeah, that's the what we want to achieve right now. The first algorithms, or the first things we have implemented, basically pull out content which is semantically relevant to the question you are asking, right, and try to come up with a plan. But obviously, there is so many ways that users can ingest them that we, that it's in the current approach not that easy that a Copilot or an AI understands the full schema of how data is ingested. If you look at very large customers we have, right, they ingesting petabytes of data per day in their own let's say in their own schemas, what they think about. And to get the DQL query completely right, Copilot would need to understand that schemas. And this is something where we need to improve and teach Copilot actually what kind of, let's say, semantics is meant with the records which are ingested, and things like that.
So we have a very long question. Actually, I think it's more around predictive AI, and it is about generative AI. But Kerry, let's pop it up on the screen. I can read it, but it's essentially about having thousands of the same problem. It's about identifying that a problem has been reoccurring, and that a problem that's potentially very mild in nature by itself could be a bigger problem when taken in context, or over time, or over the same problem occurring lots of time over time, or over different instances and so on. Could be an interesting anomaly to look at. Don't worry, we're just reading through the question. It's an interesting one.
Yeah, I think it's a great question.
I want to know what Thomas and Martin thinks about that.
I think on the high level, it goes into this direction what I just mentioned about these data conversations. Also, the idea is what I already mentioned, is that we more closely want to integrate our causal and predictive AI, which we already are having since several years, right? And combining this meaningful with generative AI in order to tackle these kinds of use cases. So, for example, if you are a developer and go to developer.dynatrace.com, you find something like a Davis Analyzer service, which provides several means of advanced analytics on top of Grail. For example, something like an anomaly detector, a forecasting algorithm, or things like that, which you can apply on top of any DQL query, which produces a time series chart. And the idea is at the end that these capabilities, which are casted into these advanced analytics services, will be combined with generative AI, and generative AI will then on its own at the end know what would be a proper one of these proper analyzers, for example, to use to answer that particular question. So should be a combination of the query queries, predefined analyzers, LLM reasoning to answer this kind of questions.
Now, kind of speaking maybe out of turn because I'm not an AI expert, I'm guessing the reason that predictive AI and causal AI are so important here is because even though LLMs could, in theory, analyze the data, they couldn't probably do it at scale or at ingest and so on. And if we want to, for instance, look at the scale of data we have and identify those patterns, we need something that's more appropriate for number crunching rather than LLMs that could, in theory, answer that question on a one-off basis, but not at scale over time.
Yeah, and also it wouldn't be very efficient because you would need to provide a lot of information. I mean, you produce so many log lines and stuff. If you just throw everything at the LLM, it would get very slow and expensive if doable at all, right? While at the same time, we already have algorithms which very efficiently can solve this kind of problems.
Yeah,
So
looking at the time
and in
series,
a deterministic way where we can rely on the outputs. So
yeah, looking at time series of disk performance, for instance, for every instance across all the hosts we are monitoring across all the disks, that probably not something that's reasonably, at least for now, with our technology with today's technology can't be done with LLMs. So mathematical model will be much more efficient and predictable in those areas.
Even if perhaps it can be done, it would be a lot slower, a lot less trustworthy. We already have a very good solution for that. So let's integrate that one.
But as you mentioned, LLMs could become acquainted with what mathematical models we have and how they can be integrated efficiently. Also, there are tons of maybe interesting also for workflows and other areas where Dynatrace have amazing building blocks, and using LLMs, we can help customers tie them together to build efficient workflows and efficient use cases without being an expert.
Yeah, that's absolutely the plan for the future. And I mean, the idea is with these data conversations that Thomas mentioned, that you should be able to do all. I mean, you don't like already get it for free, like a button, you click there and then you get whatever the answer to this relatively long question is. But you can, if you formulate it the right way, then in the future, our data conversations, then a new skill, will be able to understand the user intent, will be able to collect the necessary data, typically via a query, DQL, and then provide the output of this query, in this case, to, for example, some more classic algorithm, AI algorithm that we have, again, consume the output of that, summarize it, and present it to the user. So that's really multi-step. It's quite involved. There's a lot of information. And I mean, first of all, it has to decide on this plan, pursuing step by step. So this is typically where you would want to use these agents that are a very huge topic now in generative AI in particular, right? Agents in Dynatrace have existed for a long time, but it's a different kind of agent. But this agent system, or the LLM agents, or whatever you want to call them, many people predict that this will be the thing of 2025. We'll see if we get there, because it's very complex. There's a lot of very specific problems on top of any kind of problems that we have with LLMs. Just think of if we ask an LLM a question and we get the right answer 80% of the time, that's already quite useful. But if we have such an agentic approach where we call the LLM 10 times, and for each of these 10 times, you have an 80% chance of getting the right answer, and we need the right answer at each step, otherwise the product will be nonsense. You can do the math, or maybe you cannot. I cannot in my head, but it's probably around 10% or so, that each of these 10 times you will hit this 80% chance of getting the right answer. So you need
I'm more worried about using an LLM for alerting. And if you get it right 80% of the times, this means that 20% of the time you will wake me up for nothing. And if you run this test every minute, it means you get notified every 10 minutes with a false alarm. So maybe we do need some more deterministic approaches some elements of the pipeline.
Definitely LLMs are not the right solution for everything. I also wouldn't let it fly an airplane, right? Better things we have to do that then.
I was on call too many years to let an LLM wake me up in the middle of the night for nothing. We actually got a question from Sujay. Wondering kind of how to approach it. How do you see LLMs integrating with the one agent? think one agents are one of the most interesting technical components in Dynatrace, often our secret sauce. Where do you see one agents and LLMs coming together?
I mean, I haven't really actually thought about that one, but it would be like making on the edge compute device, which basically our one agent is, right? It's computation on the edge, being equipping it with reasoning capabilities, right? That's what it would actually mean. And the question is, what are the decisions you need to take on a, let's say, with reasoning capabilities down at the edge? So far that's not on the radar. But on the other hand, flip what Martin just said, making more skills/agents in the Copilot service available. Yes, there are plans to extend those functionality for sure, and which then can probably used.
One thing that would be of interest to me is actually the deployment. Getting coverage of observability data, configuring one agent, configuring OTel, doing hyperscaler observability. There are tons of stuff you need to configure, and maybe this is something Copilot could help in the future about understanding your architecture and making sure it's covered well from an observability perspective.
Yes, but that's basically analyzing the already. So our one agent needs to provide the proper data to the LLM to make it aware of the situation and help us with that reasoning. Will be quite a big challenge again, because I think if you consider a big application which is monitored by Dynatrace and look at the Smartscape, how many nodes and whatever you have for one particular deployment, if you would turn that into, I don't know, some markdown file with embedded Smartscape whatsoever, right, to make the LLM read it, will be quite a challenge to explain it to it in a way that it doesn't get confused and draws the right conclusions. Again, will be a rather complex, let's say, prompt engineering project at the end.
Maybe with GPT-5.
We'll see. Yeah.
Yeah, I hope we answered your question. If we got it wrong, or if you have any follow-ups, feel free to answer. Martin, kind of following up on my previous question, we asked Thomas about his view on the future. I'm wondering what you have in mind.
Yeah, so we already discussed LLM agents. I think that will be a huge topic in general and also for Dynatrace in the context of these data conversations. But one could even think of, it's kind of a paradigm on how to build the system around and with a large language model. One can even think of using it also in other places, for example, for the query generation. Now we have this very fixed workflow within the LLM system, right? We get this input, we send it to the LLM. We have, as Thomas said, first some planning and then some actual generation. But you could have multiple small steps when agent decides, first of all, okay, what information do I need? Then it retrieves information about the comments that might be important here. Then it will make a plan. It will look at the plan, will say, okay, now the plan doesn't quite look right. Let's try that again and again until it's happy, move on to the next step. So one could use this agentic paradigm maybe also in other contexts to get even better results. That's definitely also one of the things. Yeah, but mostly from our side, it will be to integrate GenAI features in more and more aspects of the product to simply make life of our customers easier. In the end, when we produce these skills, I think they are very cool, but we don't produce them because they are cool, but because we want to make life of our customers easier, right? And then there are two main aspects. One is we want to enable people who don't feel confident or just don't want to, for example, learn a query language, but they still want to be able to use it. We want to enable them to do that. At the same time, we also want to make life easier for expert users. Some of the more complex queries, it might take you half an hour to really get that right. If Davis Copilot, you can do it in half a minute, you save a lot of time. And if you do that 10 times a day, then yeah, that's really a game changer. So that's the motivation behind it. So we are thinking where, in what aspects, and in what way can we make life for our customers easier? And yeah, based on priorities, we will keep integrating then features into our product.
Mhm. So that's super interesting. We just got a follow-up question from Sujay. Let me kind of quickly go over it. Not a short one, but it's good. The more context we have in the prompt, the easier it is to get the right answer.
Just wanted to see if
Yeah, I think that's one of the things we already discussed. So this is more like then using the output of the one agents, right? Not so much on how they are run and how they're instrumented and configured. And this is in the context of these data conversations
exactly.
to be able to get all the data needed into context to answer a specific question, including very customer and tenant specific data. And then, yeah, that the LLMs do their magic. If they have all the info, usually
Exactly.
something useful comes out.
This is also some of the work that's being done by the domain experts in Kubernetes and elsewhere to figure out recommendations with and without AI to help better operate software. We're almost coming up on the hour, and as we're letting our audience think up of the last few questions they want to ask, do you guys have any final thoughts you want to share?
I mean, when it comes to, let's say, the very grand vision that basically at the end turn Dynatrace into an application operator, right? That at the end it not only looks at the data but comes up with meaningful decisions and also has actuators and does things, right? So, for example, you get an OOM kill reported in our Kubernetes app and let the LLM say, okay, what does it actually mean? And then you could ask it, okay, what could I do? And then it would typically say something, yeah, maybe you need to increase your whatever limits. And then you are not a Kubernetes expert. And then it says, how do I do that? And then it tells you, yeah, please go in your repo and find me some manifest or some configuration files. Then you copy and paste that file into the chat and say, okay, please rewrite that one such that I don't get the OOM kill anymore, right? And all of that automated. So then Dynatrace with help of LLMs would be something like that, right? So that would be the ultimate goal, that we don't only observe and tell customers, but also with some degree, obviously with a human in the loop, make suggestions what to change, automatically propose those changes in various domains, such that the user only needs to hit the button and that change is also put into action. Right?
I think this is actually an interesting take going back on our combination, because of Dynatrace already detects problems automatically using we discussed around predictive AI and also get some sense of the root cause using causal AI. So we already have let's call it a very interesting event to put into the generative AI with a lot of context. So this could be a natural entry point for LLMs because we already know something interesting is happening. We already know we want to potentially take action. So this is a great point to take all of that context and consult with an LLM about kind of what are the next steps, what's best to do, and then actually even automate that process in the future.
Yes. There are thoughts about integrating basically that you could imagine the following, that customers somehow bring their application specific troubleshooting guidelines or runbooks or whatever you like to call it to Dynatrace and tell it to Copilot, okay, see here, this is the stuff I usually do, and please combine my domain specific knowledge, my application specific knowledge. Whenever you find a problem, what should I do given that context, right? So it would combine the causal and predictive AI with the outcome, and then actually, and then Davis finds a problem, and this problem talks about, I don't know, a service slowdown or some resource contention, and then it could go and look up the customer specific information and put all that in context and make customer specific recommendation actions. Yeah.
So Sujay, I just asked a question about what we haven't covered in this session, which is the predictive and causal AI. Now we only have a few minutes, but if you kind of in 60 seconds, how would you What would you say about those elements, and where can people learn more about them?
About the predictive and causal AI, right?
Yeah.
Yeah, obviously in our documentation, right? So there is a lot of great documentation of how this is purpose built for basically for anomaly detection, forecasting, and forecast-based anomaly detection. One of the use cases I like a lot, and there have already been several posts about it, that you can use some forecasts in an automation workflow. For example, to always disk usage prediction, and when you hit some threshold, you do a resizing of that, so you don't have to wait until you run out of disk. Let Davis predict when it will run out of disk, and you do the resizing before that. And it's available in notebooks. It's very nice to play around there. You get everything visualized. You just enable the Davis analyze with Davis button in the notebooks, and then you have access to all the predictive power brought to you by Davis. And then when you explore the data in that way, you can use it to set up a Davis-powered anomaly detector in the new anomaly detection app. You can go to the problems app, which is fed by the problems which Davis has found. And there, the causal AI is used to bring to you, for example, a deployment view or let's say the whole context of entities of application services which have been analyzed during this problem analytics. That's are the main places where you can see the predictive and causal AI in action.
Very good. That's a broad topic, but I think we've got some hints on where to get started, and we can also follow Jay after the call, after this session. So, Martin, any last words from you guys?
Yeah, I think Thomas already said it almost all. I think very exciting times ahead of us. It's still a very, very rapidly evolving field in generative AI, and even more so really using all these very powerful tools and building application that's even a bit lagging behind. We are seeing very powerful models. We are still seeing a limited number of useful applications. I think ours is one of them. I hope at least our customers agree, but we will definitely work on making that even more useful. And yeah, so much to come. Yeah, we'll keep you posted and follow our developments.
Amazing. So it was great having you and chatting with you. I'm hoping the audience has enjoyed. I know I have. Any resources you guys think would be useful to share?
Well, I mean, there's our documentation, of course. Maybe we can post some links then also after the show in the comment sections, right? There's also a few blog posts which give further insights. You can Google them even, but I'm sure we can also post some links there. Yeah. Otherwise, if you already have a Dynatrace account, just try out these features that we discussed if you have access. Otherwise, ask how to get it, and we'll try to help you.
And
Awesome.
register for Perform. Lots of AI stuff will be discussed there too. So yeah.
Yeah.
Yeah,
So that's
because
our big conference coming up in beginning of February, the big Dynatrace conference, where we'll be talking about lots of new things to come.
And if you don't happen to be in Vegas in 3 weeks, you can always attend virtually online. That's also an option. So don't hesitate. And thanks, everybody. It was fun.
Thanks, Liron.
Yeah. Thanks for Liron, Thomas. Thanks, everyone.
Thanks, everyone. And bye.
Thanks, everyone.
Bye.